All right, today we are talking about one of the greatest intellectual challenges on the planet and a brand new AI that was built to conquer it. It's called AlphaProof. So, can an AI actually win a gold medal in math? I mean, for a really long time, the answer to that question was a pretty hard no. But things are changing, and honestly, way faster than anyone thought possible. And that's because, top-tier math isn't just about crunching numbers super fast. It's about this deep conceptual understanding, right? That intuition, that spark of genius that we've always thought was uniquely human, something a machine just couldn't copy. But then came 2024, and that whole idea was put to the ultimate test. And AI literally stepped into the ring, taking on the world's toughest math competition to see if what we thought was science fiction had just become reality. Okay, so what makes the International Mathematical Olympiad, the IMO, such a massive hurdle for AI? Why is it like their Mount Everest? Well, it has nothing to do with being a fast calculator. It's about a totally different kind of thinking. It's about deep, creative, multi-step reasoning that computers have always struggled with. Yeah, this really puts it into perspective. Think about games like chess or Go. AIs are masters at those, right? Because even though they're incredibly complex, they still play inside a box with fixed rules. Olympiad math? That's a whole different ballgame. It's wide open. It's like this infinite universe of ideas, and you need real creativity, real ingenuity to find your way through it. So, to even begin to tackle this infinite universe of math, the team at Google DeepMind knew they needed a totally new approach. They couldn't just build an AI that makes educated guesses. No, they needed one that could reason with absolute, guaranteed, perfect logic. I mean, you know how large language models work, right? They're amazing at talking like a human. They sound so convincing. But here's the catch. They can be completely, confidently wrong. And when you're trying to build a mathematical proof, that's a total deal breaker. You can't have any uncertainty. So the solution is something called a formal system. A great example is a language called Lean. The best way to think about it is like it's math with a super strict, unbreakable grammar. Every single step, every single line of a proof gets checked automatically. That means you have a 100% guarantee that it's logically correct. No mistakes. And this is how AlphaProof actually uses it. It's got this core reasoning loop that's always running. First, it looks at where the proof is right now. Then, a part of the AI, the proof network, suggests what it thinks is the best next step. And then, a really powerful search algorithm kicks in and explores millions, literally millions, of possible paths to find one that works and gets to a final, verified solution. Okay, so you've got this awesome system, but how do you actually teach an AI to be a mathematician? I mean, you can't just hand it a textbook, right? It has to learn by doing, by practicing, and it has to do it on a scale we can barely imagine. The training is this incredible multi-stage marathon. First up, it just absorbs a mind-boggling amount of text and code. We're talking 300 billion tokens just to learn the basics of language and logic. Then, it gets more specific. It studies human written proofs to learn the special language of Lean. And finally, the real magic happens, reinforcement learning. It just starts solving millions and millions of problems on its own, discovering brand new strategies that go way beyond what it was initially taught. But right there, they had a huge bottleneck. To learn by practice, the AI needed a gigantic curriculum of problems already written in that strict Lean language. So what did they do? The solution was just brilliant. They built another AI, an auto-formalization system, whose only job was to translate millions of math problems from plain English into that formal Lean code. Get this. That one system generated a curriculum of 80 million formal math problems. Just let that number sink in. 80 million. The scale is just staggering. It created this training data set that is so much bigger than anything humans could have ever put together on their own. But okay, even after all that training, you're still going to face problems that are just next-level difficult. And for those, AlphaProof has a secret weapon. And the cool part is, it doesn't even use it during its main training. It saves it for the test itself. So what happens when you hit a total wall? You know, when you face a problem that's so tricky and so unique that all your general training just isn't enough to solve it? Well, you basically invent a whole new kind of workout on the fly. So think of its normal training like a general fitness plan. It makes it good at all kinds of math. But then you have this other thing, test time reinforcement learning. When it gets stuck on one super hard problem, the AI creates a custom training program just for that one problem. It generates hundreds of thousands of similar, slightly easier problems, and then it drills itself on them over and over, essentially becoming a world-class expert on that very specific challenge. So you've got it all, the perfect logic system, the insane training regimen, this incredible test time power-up, and it all came down to this one moment. The big showdown, the live 2024 International Mathematical Olympiad. So, the big question, how did it do? The AI system scored 28 points. Now, to get a silver medal, you needed 21 points. To get a gold, you needed 29. It was that close. For the very first time in history, an AI performed at a silver medal level. Just incredible. Now, if we break it down, the system solved 4 out of the 6 problems. But look at problem P6. That's the one you need to see. AlphaProof solved what everyone agreed was the hardest problem in the entire competition. A problem that only 5 human students, out of over 600 of the world's brightest, were able to solve. And this is a big deal. The researchers themselves put it perfectly, saying this demonstrates a profound advance in the potential of AI for mathematical reasoning, even when applied to problems renowned for their difficulty and requirement for novel insights. Basically, it's a huge leap forward. So, what does all this mean? What happens now? Where do we go from here after such a landmark achievement? So let's recap the takeaways here. First, this was a truly landmark moment. It's the first time an AI has ever hit medal-level performance at the IMO. Second, it gives us a whole new way of thinking about AI, this combination of smart learning with the rock-solid logic of formal systems. Now, there's still a long way to go, right? These solutions took days of computer time, way more than a human. But the goal here isn't to replace mathematicians. The real goal is to build an amazing AI tool that can help us solve the really complex problems of the future, maybe even speed up scientific discovery itself. And that really leaves us with one big, thought-provoking question. If AI is starting to get a handle on the pure, creative logic of mathematics, what's next? What new worlds of science, of technology, what new levels of understanding could it help us discover?